We just learned about how a factory pattern is implemented in order to keep the instances of an object completely abstracted away from client code. Now, an important part of using the factory pattern and avoiding recompiling and re-releasing code to production was using reflection. So it's worth a while to dive a little deeper into what is reflection and how it can help us. Now, in the example that we just saw, reflection played a very important role, and it's really worth talking about this a little bit more. It was reflection which allowed us to completely decouple which instance of a class is created and allow us to change this as runtime. So, what is reflection? Reflection is a way to invoke methods of objects on the fly at runtime. And the constructor of an object is also included in the method that can be invoked at runtime. Thus, reflection allows us to instantiate objects at runtime without knowing beforehand what that object is. Reflection is available in most important languages now, Java, C#, etc. But it's very, very important to know that reflection is slow and complicated. Using reflection in your program means that your program takes a huge performance hit. A method call via reflection can take 10 times longer than usual. And if it's on a critical path, this means that you've slowed down the most important and the most used path in your program. This can be a very big deal if a user is waiting on information which passes through this critical path, which you've just slowed down because of reflection. So typically, many programmers do not like reflection and don't use it a lot. Now that we've spoken about the downsides of reflection, you might want to use the factory pattern without using reflection. Yes, this is possible, and in fact, there are a whole host of programmers who do exactly this. So what's required now? We would definitely need to edit code at switchover time. There is no other option because we have to move from MS SQL database to the Oracle database, and this cannot be done without editing code. But we'd still like to do the switchover in a relatively smart way and not go down the path of instantiating separate objects once before switchover and once after switchover. So what is this smart way? We can have two factory classes. One called the Oracle Database Factory and the other called the MS SQL Database Factory. As is obvious from the names, Oracle Database Factory would be responsible for instantiating all instances of the Oracle database, which implements the iDatabase interface. Similarly, the MS SQL Database Factory would be responsible for instantiating all instances of the MS SQL database. So each of these factories only return the database objects of the specific type. Now, both of these database factories implement from the same abstract base class. We'll call it Abstract Database Factory. If you think about it, it's not an interface that they need to implement. Instead, it's an abstract base class because they actually share implementation details. The factories which instantiate different database objects may have a lot of nitty-gritty code which are in common, whether it's an Oracle Database Factory or a MS SQL Database Factory. So we'll have them both derived from the same Abstract Database Factory class. Now, you can imagine that most of the implementation details in these two classes is shared. We pull in all that shared code into the abstract base class and leave the exact Oracle Database Factory and the MS SQL Database Factory as light as possible. So this is what the hierarchy looks like. We have the Abstract Database Factory and the Oracle Database Factory and the MS SQL Database Factory derives from that and shares the implementation details which are pulled into Abstract Database Factory. Things are never quite real unless we look at some code. So let's take a look at some code which instantiates two database factories and sets up an abstract-based factory which is the parent of these two. So take a look at the code on screen. We have the abstract class database factory which has a whole bunch of shared implementations, primarily the read from config. It has an abstract get database which returns an instance of a database, which implements the iDatabase interface. Note that this method is not static. Let's look at this step by step. Step 1. Create the abstract factory object and leave out the implementation of the get database method. This is a non-static method with no implementation in the parent class. That's because the parent class is only for shared behaviors. The next thing is to note that the get database method is no longer static. This is because we want the child classes to override this method and provide their own implementation to instantiate a database. A static method cannot be overridden, which is why the get database method is no longer static. Step 3 is to create the actual factory objects. Each of these factory objects, the MS SQL database factory, as well as the Oracle database factory, extends database factory, uses the share implementation, and then instantiates a separate database. One instantiates the MS SQL database, and the other instantiates the Oracle database. The third step is to instantiate the correct factory when we try to get the database from it and use that to get the actual database object. So we have database factory equals new MS SQL database factory. This is pre-switchover. And then the iDatabase variable will simply call database factory.getDatabase. Now, say that this new CIO has joined the company and we want to move over to the Oracle database. All we need to do is to edit that line which gets the correct database factory, so that now we use an Oracle factory rather than a MS SQL Server factory. That is the one line we need to edit. Remember, because we don't use reflection, we need to actually recompile and re-release code to production. This is a variation of the factory pattern and is called the abstract factory pattern. Now, it's a very legit question to ask. Why is this abstract factory pattern helping me in any way? I could have simply instantiated the database directly. The abstract factory pattern still gives us one huge advantage. That is, the implementation details of how an object of database type is instantiated is completely hidden and decoupled from the user. This is a big deal. Right now, we are instantiating an object by simply newing it up and passing in no parameters. Normally, instantiating a database can be a bigger deal. There might be a whole bunch of configuration we want to pass in, for instance. We are hiding that bit of code away behind the database factory. And that is what the abstract factory pattern gives us. Using reflection would have helped us avoid re-releasing code. However, the abstract factory pattern still helps us keep the client code clean and not have the client code know about the details of creating any object. What are some of the other advantages? The abstract factory pattern is generally used to create families of related products. This kind of ties in a whole family of products, which in our case is databases, together by using the same abstract factory. The other advantages are We don't use reflection. That is something that is known and which we've spoken about. And another thing is, if we have different versions of Oracle and MS SQL databases, say we have 3 different versions of Oracle, all of those can be put in the same database factory. So we've kind of made a logical unit of database factory which knows how to instantiate different versions of the same database. So this logical grouping is also enabled by using the abstract factory pattern. That is one way of logically grouping different versions of the same database. Or if we had different implementation not only of the database but also of the commands or connections for each type of database. Oracle had its own set of commands and connections, and MS SQL Server had its own set of commands and connections. This can also be dealt with cleanly using the abstract factory pattern. We've spoken a whole lot about what we should use while using the factory method or the abstract factory pattern. There is one solution to this problem of creating different instances of the same family of objects, which we should never ever use. Code like this should never ever be written, and I'll give you good reasons why that's the case. So let's look at what is the solution which we should avoid like the plague. Take a look at the screen. Here we have a database factory which takes in the database type that you want to instantiate as a string, which is fine. Now it has a whole bunch of if statements which checks what type of database it is that you want to create. And then whenever it finds a match, it returns that type of database. Code like this is a faux pas. It's unacceptable, and it's kind of like picking your nose in public. Why is that? This is because each time you add a new database, this particular class's code needs to be updated. And it's kind of random. You have this database factory which should just work without knowing all the types of database that you have, but it doesn't. So when you instantiate a new database factory or a new database, you'll have to go in and edit this code. This code will change really often. As and when you add databases, everyone will have to come in and change this particular method. That's not cool for a whole variety of reasons. Each time your CIO changes, you'll go in and change this piece of code. This will end up completely making this particular file unmaintainable with a lot of spaghetti code. It's clean now, but what if you were calculating all the arguments to be passed into a database in this code as well? Once you think of code like that, you'll realize that having it all in one file is just going to cause an explosion of complexity and a lot of spaghetti code. There is a very important design principle which this code also violates. Code should be open for extension but closed for modification. This is the underlying principle for all code that you write, which means anyone wanting to use your code should be able to extend it and get their functionality from what you've provided. However, your code should be closed for modification. This is the open-close principle, and the code that you see on screen violates this. So please don't do this except as an example. You'll find tons of examples on the web which use this to define the factory pattern. They work fine as an example while explaining a concept, but in real production code, avoid writing stuff like this. Now that we've learned a whole bunch, let's quickly summarize where we use the factory pattern. So we use the factory pattern under two conditions. We have a bunch of alternative classes and only one of these can be used at a time. All these classes achieve the same objective and you want to use just one. That's a great place to use the factory pattern. Another case would be you want to make it as easy as possible to add new choices to the classes that you have. and you want to make it as easy as possible for the client code to pick between these classes. The factory pattern and the abstract factory pattern both are great in these circumstances.